Welcome to this video about angular measurement units in the SI system. Today, we'll be exploring two important angle units, the radian and the steradian. These units help us quantify angles in different dimensions and are fundamental to many areas of science and engineering. Let's begin with the radian, which is the SI unit for measuring plane angles, that is, angles in two dimensions. The symbol for radian is rad, and it's a dimensionless unit because it's defined as a ratio of two lengths. So what exactly is a radian? Imagine we have a circle with radius r. One radian is defined as the angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. So when the arc length equals the radius, the angle at the center is exactly 1 radian. Since the circumference of a circle is 2 pi times the radius, a complete circle contains 2 pi radians. This is why a full circle is equal to 2 pi, or approximately 6.28 radians. This also means 1 radian is approximately 57.3 degrees. Let's compare radians with the more familiar degrees. In degrees, a full circle is 360 degrees, while in radians it's 2 pi radians, or about 6.28. To convert between these units, 1 radian equals 180 divided by pi degrees, and 1 degree equals pi divided by 180 radians. Some common values to remember. 90 degrees equals pi over 2 radians, 180 degrees equals pi radians, 270 degrees equals 3 pi over 2 radians. The radian makes many mathematical formulas simpler and more elegant. For example, in calculus, the derivatives of sine and cosine are much cleaner when using radians. The derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. These simple relationships only hold true when x is measured in radians. Radians are also essential in physics, especially for describing periodic motion like waves, oscillations, and rotational dynamics. Now, let's move from 2 dimensions to 3 dimensions and discuss the steradian. The steradian, symbolized as SR, is the SI unit for measuring solid angles in 3-dimensional space. Like the radian, the steradian is also a dimensionless unit, as it represents a ratio of areas. To understand what a steradian is, let's visualize it. Imagine we have a sphere with radius r. 1 steradian is defined as the solid angle subtended at the center of the sphere by a portion of the surface area equal to the radius squared. So when a patch on the sphere has an area equal to r squared, the solid angle subtended at the center is exactly 1 steradian. Since the total surface area of a sphere is 4 pi, r squared, a complete sphere contains 4 pi steradians, which is approximately 12.57 steradians. Steradians are particularly useful in fields that deal with radiation and light. For example, in radiometry and photometry, we use steradians to measure radiant intensity, which is measured in watts per steradian, and luminous intensity, measured in candela, which is defined as lumens per steradian. Steradians are also crucial in astronomy, where they help describe the angular size of celestial objects and the field of view of telescopes. Let's compare and contrast radians and steradians. Both are dimensionless SI units used for measuring angles. The key difference is that radians measure angles in a plane 2D, while steradians measure solid angles in space 3D. A complete circle contains 2 pi radians, while a complete sphere contains 4 pi steradians. Radians are defined as the ratio of arc length to radius, while steradians are defined as the ratio of surface area to radius squared. To summarize what we've learned, radians and steradians are the SI units for measuring angles in 2 and 3 dimensions. They're both dimensionless units that make mathematical formulas more elegant and are essential in many scientific and engineering applications. Understanding these units helps us navigate the angular relationships in mathematics, physics, engineering, and many other scientific fields. Thank you for watching, and I hope this video has given you a clear understanding of these important measurement units.